right, today we are going to do 3.2.2 day one notes, which is the greatest common factor. So if you guys remember the other day, we discussed that a factor is the numbers that multiply to your numbers. So for example, if we were looking at the number 12, our factors would be 1 times 12, we would have 2 times 6, and 3 times 4 would all work out, because all those numbers multiply up to give us 12. So to start, we're just going to review actually multiplying polynomials together. So I'm going to do warm-up problem number 3 with you guys, and then I'll have you do number 1 and 2 on your own. So when we multiply, we're going to distribute through. And remember, when you multiply terms together, you add up their exponents. So x doesn't have an exponent there. However, you can draw in an invisible 1. So invisible 1 right there. And we're going to add the exponents together. So we would have negative 2. 2 plus 1 would give us x cubed. And then we have the y. And then negative 2 times 5 would give us negative 10. We have the x squared, and then y to the first times y to the fourth. When you add those together, you would get y to the fifth. So that would be your final answer of the polynomial multiplied together. So take a second and try numbers 1 and 2, and then you can submit your answers. All right. So moving on to actually factoring out the greatest common factor. So this whole section focuses on what we call factoring, which is the exact opposite of multiplying polynomials together. And when you factor, your first step is always going to be factoring out what we call the greatest common factor. And the greatest common factor is the largest number and variable that divides out of the polynomial. It has to divide out of everything. So for example, if we look at number 1, we have 3x squared and 18. Thinking about the numbers 3 and 18, what is the largest thing that divides into 3 and 18? Well, 3 divides into both, right? You could divide 3 out of both of them. So our GCF for this expression would be 3, right? And the way that we would kind of write our final answer is we would write the 3 on the outside, and then what we're left over with once we divide out. So if I divided this first term by 3, those would cancel, and we'd be left with just x squared. And if I divide 18 by 3, we would be left with just 6. And this would be our final answer factored out. If you wanted to check if you did it correctly, you could distribute it back through, and you should end up with the original problem. If we look at number 2, we have 25z minus 10. So thinking about the numbers 25 and 10, we have to think, what is the biggest number that divides into both 25 and 10? So you can look at your factor chart if you need to, but the biggest number that divides into both of these is going to be 5. So what we can do is we're going to divide both of these by 5. So we'll pull a 5 to the outside, and then write what we're left over with once we divide. So 25 divided by 5 leaves us with 5, and then we still have the z, minus 10 divided by 5 leaves us with 2. And then that would be our final answer with our GCF factored out. The way that you know that you're taking the greatest, because you have to take out the greatest, the biggest number that goes into both, is that what's left over in the inside of your parentheses should not have anything in common. So like 5 and 2, they're relatively prime. They don't share any terms in common. All right, so take a look at number 3, and I want you to think, what is the biggest number that divides into all three of those terms. Okay, so you should have gotten 2, right? 2 is the biggest number and variable that divides into all three of those terms. So our GCF for this problem would be 2. So what we're going to do is we're going to divide 2 out of each of those terms. So 2 goes on the outside, and if we divide 2 out, we're left with 4, and then we have the c squared. If we divide it out of the middle term, we're left with just 2c. And if we divide it out of the last term, we are left with just 1. So that would be our final answer there. All right. So the first 3 that we just did, the GCF was only a number. Now we're going to look and see, well, maybe we'll have more than just a number we can take out. So just looking here at number 4, and I'm thinking about the GCF, I need to see what's the biggest number that divides into both 16 and 4. And that happens to be 4. So we can pull out a 4. But then also we have to look at the variable, the letter. And if you notice, these both have B's in them. So the most B's that I could take out of both of them is only 1 B, right? Because this one has 2 B's to give away, but this one only has 1 B. So the most you could take from both of them is 1 B. So that's why the GCF would be 4B. So we take that, that's our GCF, put that on the outside, and we're going to divide each of these by 4B. So 16 divided by 4 is just 4. And then b squared divided by b. So remember, when we divide numbers, we subtract their exponents. So I would do 2 minus 1, which is just b to the 1, or b. All right, so this would be 4b. And then 4b divided by 4b is just 1. So that would be your final answer. If you're unsure, remember, you can always try and distribute this back out and make sure that you end up with the original problem, which, messed that up. You would 16b squared plus 4b, which is what our original problem was, so that is correct. All right, looking at number 5 here, our GCF for this, I have 7, I have 21, and I have 14. So if I, look at my factor list or whatever, you should see that the number that goes into all 3 of these terms would be 7. As far as the variable goes, unfortunately, we're not going to be able to take out any sort of variable because 14 doesn't have any t with it. So there's no way I could take a t out because 14 doesn't even have 1 to give up. So our GCF is just going to be 7, and we can divide each term by 7. And when we do that, we're left with t cubed minus, that would leave us with negative 3t squared, and that would leave us with 2 as our final answer. All right. And then lastly, number 6, why don't you guys take a look at that and see, what do you think your GCF is going to be? What's the biggest number you could take out of all 3 of these terms? And how many x's can you take from all 3? So what's the most x's you can take from all 3? All right, so you should have gotten that 3 divides into all the terms. And then as far as the most x's, this one has 4 to give up, this one has 3 to give up, and this one has 2 to give up. So the most that they all could give up would be 2. So the GCF would be 3x squared. Okay, so that's what we'll put on the outside of our parentheses. And we'll just divide each term by 3x squared. So if we take it out of this first one, the 3's cancel out. And then remember, you could subtract the exponents. So 4 minus 2 leaves us with 2. Negative 9 divided by 3 is just negative 3. And 3 minus 2 is 1, so that's just 3x. And then 6 divided by 3 is 2. And then the x squareds, those cancel. So that would be our final answer. And once again, you should check, your final answer that they don't share anything in common in the parentheses, which they don't. Okay. Number 7 is kind of an interesting one, because if I look here at number 7, I think about 6 and I think about 11, and I know 1, 6, 3, and 2 are the only numbers that divide into 6. The only thing that divides into 11 is 1 and 11. So since the only factor they share in common is 1, there's no need to take out a 1. So this doesn't have a GCF. This is what we would call prime, right? You can't take out a GCF, so it's just the original problem is the answer. It's prime. Right? And then for number 8, we look here, we have to find our GCF. So we have negative 6, negative 12, and we have 30. So the biggest number that divides into 6, 12, and 30 would be 6. However, this is something very important to note. Since the first number is negative, you have to make sure you take out a negative 6. So that is something to note. When the first term is negative, the GCF should be negative, okay? So since negative 6 was negative, we had to take out a negative, right? So make sure you note that. And then as far as the y's go, this one has 3 y's, this one has 2 y's, and this only has 1 y. So the most y's that they could all give me would be 1 y. So the GCF would be negative 6y. So we're going to factor that out. And when we do that, we're left over with, so the negative 6's cancel, and then you would subtract 3 minus 1, which would give us y squared. Divide by negative 6y, and negative 12 divided by negative 6 is a positive 2. And then 2 minus 1 is just 1, so y to the 1. And then 30y divided by negative 6y. So 30 divided by negative 6 is negative 5. And then the y's cancel out. So that would be your final answer. All right. So go ahead and try number 9 on your own. What's your GCF and what would the final factoring look like? All right. The next part of the lesson is solving quadratics by factoring. So when we solve, that means that it's going to have an equal sign in it. And our final answer is going to be x equals or a equals or t equals, whatever the variable is. So in order to correctly solve these problems, we're going to have to think about something called the zero product property. And the zero product property means that when you multiply numbers together, because that's what product means, to multiply. So when you multiply numbers together, if one of those numbers is 0, the answer is automatically 0. So let's think about it. If I had 4 times 0, it would equal 0. If I had 28 times 0, it would equal 0. If I had negative 121 times 0, it would equal 0, right? Anything times 0 is always going to equal 0. So that's why the zero product property exists. So the same rule will apply when we multiply factors together, right? We'd multiply this factor times this factor. If it equals 0, that means this either has to equal 0 or this has to equal 0. And then you would solve each of those little equations to get your two answers. All right. So you can see here, it says with quadratics in GCF, this only works for binomials. So that's two terms. And that's what we're going to look at right now for the notes. All right. So we're going to start this out the same way that we were doing the GCF on the front page. We're going to try and figure out what is the biggest variable or number that goes into both terms. So with number 10, b squared doesn't even have a number with it. So I know I'm not going to be factoring out any sort of number. However, they both have a b in them, right? This has two b's and this has one b. So the most b's I could take out from both terms would be one b. So my GCF in this problem is just b. So I'm going to put a b on the outside. And then if I divide b out of here, I'm left with just one b. And if I divide b out of here, I'm left with just minus 10. All right, so that's our first step, factor out the GCF. The second step now is, since this equals 0, that means either b has to equal 0 or b minus 10 has to equal 0. So b equals 0, that's already by itself. I don't have to do any math there. But b minus 10 equals 0 means that I have to add 10 to both sides. So that's what we'll do. And we'll be left with b equals 10. So our two answers here are b equals 0 or b equals 10. Because if I plugged either of those answers into this equation right here, the answer would be 0. So for number 11, our GCF, we look at these two terms, 21 t squared and negative 14. They don't share a variable in common because 14 doesn't even have a t with it. But when I think about the numbers 21 and 14, the factor that divides into both those numbers, the biggest one, would be 7. So I'm going to factor out a 7. And when I do that, factor out a 7, divide by 7, 21 divided by 7 gives me 3. And then I have the t squared. And 14 divided by 7 is 2. All right, so just like before, this or this has to equal 0. So we're going to do 7 equals 0 or 3t squared minus 2 equals 0. But you're probably thinking to yourself, 7 doesn't equal 0, right? That's not true. So just cross it out, because 7 doesn't equal 0. That doesn't even have a variable in it. You're not going to do anything with it. However, this 3t squared minus 2 we can solve. And we'll use our skills that we learned yesterday to solve this. So remember, we get rid of addition and subtraction first. So I would add 2 to both sides. So we get 3t squared equals 2. Then next we would get rid of what we're multiplying or dividing. So that would be the 3. Cancel out. 2/3 is an ugly decimal, so I'm going to keep it as the fraction. So now we have t squared equals 2/3. All right. And then our final step to get rid of squaring something, we would square root it. So I'm going to square root, and as we talked about, you need to remember that plus or minus. So plus or minus the square root of 2/3. It's not a pretty answer. You can't break it down, so that would be your final answer. T equals plus or minus the square root of 2/3. All right. So if we look at number 12, we're going to take out our greatest common factor. For number 12, we're going to have 4. 4 is the number that divides into both these terms, and you can't take out an x because 16 doesn't have any sort of x with it. So we will factor out a 4 from both terms. So 4 divided by 4 is just 1, so I'm not even going to write it. And 16 divided by 4 is 4. That, and it's equal to 0. So this is when we can separate it. We're going to have to do 4 equals 0 or x squared minus 4 equals 0. Okay. And of course, 4 does not equal 0, so we can cross that out, just like we did in the last problem. And then we can go ahead and solve x squared minus 4 equals 0. So to get x by itself, the first thing we would do would be to add 4 to both sides. So we have x squared equals 4. And then our last step would be to square root. So the square root of 4 is plus or minus, positive or negative, 2. So those would be your 2 answers. A lot of times you're going to be getting 2 answers for these. Okay, so we'll do a couple more. If we look here at number 13, we have 9x squared and negative x. So thinking about the greatest common factor, what goes into both of these? Well, they don't share any numbers in common, so we can't take out a number. However, they both have an x. So we can't take out x squared because this only has one x to give up, so our GCF is just going to be x. So we can go ahead and divide out x from both terms. So 9x squared divided by x, remember you subtract the exponent, so that'll leave us with 9 and x minus x divided by x just cancels out. So when you divide and everything cancels out, you're left with just 1. So it'd be 9x minus 1 equals 0. Okay. Now we're going to set each piece equal to 0 because of the 0 product property, this could equal 0 or this could equal 0. So just like earlier, we don't have to do any math for this one because x is already by itself. So that's one of our answers. For this one, though, we actually have to solve the equation. So we'd add 1 to both sides, 9x equals 1, divide by 9, and we would get x equals 1/9. All right, so those are our 2 answers, x equals 0 or x equals 1/9. Okay. Now, for number 14, when we're thinking about our GCF, we have the numbers 5 and 3. Well, 5 and 3 are both prime numbers. They don't share anything in common besides 1. And we can't take out any sort of z's because 3 doesn't have any z that goes with it. So as far as GCF goes, this does not have a GCF. So the way that you're going to go about doing this is you're literally just going to solve the equation 5z squared minus 3 equals 0, like what we did yesterday. So the reverse PEMDAS. So you'll get rid of the 3 first by adding to both sides. So 5z squared equals 3. And then you can divide both sides by 5. So we have z squared equals 3/5. And then your final step would be to square root. And remember, when you square root, you need to include plus or minus. So plus or minus the square root of 3/5. So a lot of times you'll just leave those as fractions if you get a decimal when you try to divide them. Once again, though, we get the 2 answers just like what we did for when we did the problem above. Okay, and the last one that I'll do with you, number 15. So thinking about our GCF, we need to figure out what number divides into both 5x squared and negative 20x. So both 5 and, well, 5 goes into both 5 and 20. So that's going to be our number. And then both of these have x's that they can give up, right? This has two x's and this has one x. So the most x's they could take from both terms would be an x. So our GCF is going to be 5x. We could divide up 5x from both of those. So when we pull out a 5x, we're left over with just x from our first term, and then negative 20 divided by 5 is negative 4, and then the x's cancel out. It still equals 0. Right? So then we can go ahead and set each piece equal to 0. And solve. So divide both sides by 5 for this one, and we get x equals 0. So that's one of our answers. Or, and then for this one, we can add 4 to both sides, and we get x equals 4. So those are your two answers, x equals 0 or x equals 4. So go ahead and try the next 3 on your own. Think about, you could get imaginary answers. That is possible.